Hello, my name is Ricardo Arce, and in this video you'll learn to name the sodium hydroxide ion using the nomenclature rules about its shape and bonding and explore how it is used in real-world applications. So, naming rules of sodium hydroxide. Sodium hydroxide is named based on their bond type and the common polyatomic ion name of OH, which is hydroxide. Sodium hydroxide is ionic, so the naming is the cation, then the anion. Sodium hydroxide is an ionic compound because it is formed from a metal, sodium, which has a charge of +1, and a nonmetal polyatomic ion, hydroxide, which has a charge of -1. This means that the polyatomic ion hydroxide steals an electron from sodium, making sodium ion Na+, and the hydroxide ion OH-. These combine in sodium hydroxide. So for the shape of sodium hydroxide, the shape of sodium hydroxide is not determined by one molecule, but rather as a crystal or lattice structure. The lattice structure is a symmetrical repeating structure of a compound. To represent ionic bonds which form lattices, you can't use a 2D model of the compound like the covalent bond is represented, instead with 3D models. The specific type of lattice, orthorhombic, tells you that the length of each side of the crystal, like structures, are all unequal, giving it weak points. This makes the solid form of NaOH, sodium hydroxide, flaky and easily broken. You can draw the Lewis diagram of sodium and hydroxide separately by adding the brackets and charges to help represent the ionic bond, as you see at the bottom. You can't represent sodium hydroxide with an electron geometry because it is for covalent compounds. So you can only represent the electron geometry of OH- and the bond angles, which look as follows. It has 4 electron domains, which means it is tetrahedral and has an ideal bond angle of 109.5 degrees. So some real-world applications of sodium hydroxide. You'll find them in household cleaners, in the textile industry, and in wastewater treatment. In household cleaners, it'll be things like bar soap, drain cleaners, oven cleaners. In the textiles, you'll be scoring cotton, just like cleaning it, making the color go back. And wastewater treatment is neutralizing acidic waste. This is possible because of the high polarity of sodium hydroxide, as well as being a very strong base. It easily dissociates in water, meaning it's hydrophilic, and can dissolve fats and neutralize acids. Thank you for listening to my presentation on sodium hydroxide.